In this lesson, I'll create both a VR and panoramic output, and I'll start by setting up a VR output for this model. Since the camera moves around the stationary model in a VR output, the most important consideration is setting up the camera so the model doesn't clip when it rotates. I'll start by copy and pasting the active free camera, double-clicking it to activate it, and renaming it VR. Next, I'll center the model in the viewport by activating the yellow Model Selection tool from the main toolbar, holding Ctrl and Shift, then left-clicking on the model. This not only sets the look-at point to be the center of the model, but also sets the zoom so the camera won't clip the model at any angle. I can then zoom in slightly on my model to better fill the viewport. Likewise, I can always change the aspect ratio of the VR camera to also make sure the model doesn't clip. To make sure it doesn't clip in the VR output, I'll go to the Cameras tab and set the latitude to 50. Then move the longitude slider through a full spin. If I noticed that there was a lot of unused space around the model at this angle, I could then zoom in and recheck for clipping to better fill the viewport with my model. Once I know there's no clipping, I can then use this exact latitude as part of the final VR output settings. Since a VR render only uses the look-at point and distance of the camera, I don't have to worry about what exactly the camera is looking at in the viewport when I kick off the VR render. I'll go to the output options from the main toolbar and select Render. I'll change the output mode to VR, and the VR output settings appear. The viewing angle is set by the start and end angles, and should match the angles checked when setting up the camera. So I'll set the start angle to 0 and the end angle to 50. The number of orbits sets the number of rotations around the model and will be done between the start and end angles, so increasing the number of orbits will result in smoother vertical motion in the final output. I'll use 3 for this example. Images per orbit sets the number of images that will make up each orbit, so increasing this will result in smoother horizontal motion in the final output. I'll use 12 for this example. Since I have 3 orbits and 12 images per orbit, Visualize will render and stitch together 36 images to create the final interactive VR output. I'll set the resolution to 1280 by 960 for this example, select the fast render mode, and click Render. Since there are multiple images that will be rendered, using higher class or multiple NVIDIA graphics cards can really improve render speeds when rendering VR outputs. Once completed, the VR render outputs a folder containing a data folder and an HTML link. The link is optimized for Chrome, so when I double-click it, it brings up the interactive environment in the Chrome browser where I can interact with it. The data folder then contains all the data needed for the output type, including the set of the still images stitched together to create the output. Since the HTML is just a link to the completed images, it must always be stored with the data folder, but doesn't require internet access to be used. Back in the Render Output options, I'll go over the other interactive output, Panoramik. This interactive output stitches together 6 rendered images to form a 360-degree panorama around the active camera. With this in mind, the most important considerations when setting up a panoramic render are the camera position and focal length. I'll select the option, and notice that unlike the VR output, there are no additional output options to set. I therefore only need to set the resolution and render setting before I start the render. I'll switch to a finished output folder and notice it also has a data folder and HTML link. Like the VR output, these folders need to be in the same location to work, and I don't need internet access to view the HTML. I'll double-click the link to open it in Chrome, and as I move the camera by clicking and dragging, notice the photorealistic visual quality you can achieve in Visualize, which is historically very hard to achieve for interior spaces. Keep in mind that since this is an enclosed interior lit mostly by these interior lights and whatever light spills through the portholes, the accurate render mode is the only renderer selection that will create truly photorealistic results. Additionally, enclosed interior spaces also require higher accurate pass counts. To get this noise-free output, for example, around 2,000 passes were needed. If your fully enclosed renders still have visual noise at 2000 passes, then increasing the pass count to 5000 or more may be necessary to get a noise-free render.